Thank you, Paul, and thank you for hosting me for a day here. It's always a pleasure. There's always interesting things going on. I'm not as wonderful as he said. It's all smoke and mirrors. You just give the impression that you do a lot by tweeting, and then people think that you're doing other things, and it's not actually true. You're late, Pierre. Yeah. Well, it could have been worse. Like the Argentinians won't be here for another 2 hours. Okay. So I'm going to talk a little bit about communications and why we particularly have an issue with communications that actually is not intrinsic to us. It's not our problem that we are unable to communicate our science. The problem is the situation that we find ourselves in. So the odds on clear communication in the situation we find ourselves are actually very short, and it's worth thinking about why that has occurred and how we as individuals and as a community can kind of work around it and avoid some of the biggest pitfalls. So let's kind of break this down. So we're working in a science, and for that I'm talking mainly about climate science, but Earth science more generally, in a science that has become politicized, right? So what do I mean by that? So science gets politicized when the results that we're talking about really only appear in public when they are talking about, or they appear to be projecting onto something that people care far more about than science. Right? So people like science, people go, gee whiz, science, and they're impressed by what we do. But the reason why things hit the headlines related to climate science are not because we think it's interesting, it's because other people think it's interesting, often for very different reasons. The new stuff that comes out, how many papers are we publishing every year? It's tens of thousands of papers. How many of them get a headline in the Independent or the Guardian or the Telegraph? It's a tiny, tiny fraction of those papers. So why are those being selected out of all the work that we're doing? Well, it's because they project onto some other question. A political question, an economic question, an ethical question, a religious question sometimes. And the converse to this is this notion of scientized politics, right? Because science is so well regarded in society. Everybody wants their stuff to be scientific, right? So you add an extra decimal point to your random number that you just thought of in order to make it sound more scientific. I read that in 37.2% of studies. People like having science on their side when they're projecting something or trying to change something. So you'll find politicians say, no, in a study, blah, 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 it said that my policy is going to be doing so much better for the world. Or we can't do this because of this study. But what happens then is that people who aren't scientists start arguing about scientific studies in fora where there's none of the rigor of the peer review process, there's none of the back and forth that you would get at a conference, but it's basically just talking points, right? So somebody has a talking point that quotes some random scientific thing out of context. The other person, who obviously knows nothing about the science, quotes another one back at them, and so they're arguing about 15th century tree rings as if that had any relevance to any decision that anybody would actually want to make. Even in the 15th century, people didn't argue about tree rings. So, we're not going to be. It's a fake political discussion that sounds kind of sciencey, that references science, but it has none of the norms of a scientific discussion. So you have this thing. There's obviously nothing to do with the real scientific debate. And then you have this kind of scienciness, which is basically there just to make a point, right? To score points, as a lawyer would argue a case, as opposed to a scientist making a case. And so in such circumstances, you get a lot of cherry picking, you get a lot of straw man arguments, you get a lot of totally red herrings, so things that are true but totally irrelevant for the point at hand. But don't you know that water vapor is a greenhouse gas? Yes, actually, I did know that. So you get a lot of, I'll skip that. So there are good consequences and bad consequences for this, right? This is just the situation that we find ourselves in. It is not of our making. So there are good consequences. The good consequence is that if you do have work that projects onto the public debate, it is easier to get it into Nature and Science, regardless of what the editors tell you. They're fibbing. It is easier if you have a public interest in the results of your study. So when we write to the editors of Nature and Science, we often write, this is important because this is something that people have been discussing in public. Whether we think that that's a sensible thing to be discussing or not is generally not stated in such a letter. And so what we find then is that the high-profile papers in Nature, Science, PNAS drive and enhance the importance of this kind of fake public debate that we don't really think is a real debate, but that we're using in order to push our own stuff. And so that's good for us personally, right? The authors of those papers, they're higher profile and they get a lot of citations. If they're not very good papers, then there are negative consequences as well, because now everybody knows that you wrote that paper that was not very good. But mostly, the bigger exposure you have, the better it is for your career. You do get more media coverage. People are knocking on your door trying to ask you questions. What does it all mean? What should we do? What do you think about nuclear power? What do you think about this? The stuff that's totally irrelevant to what you actually did in the paper and pretty much irrelevant to the public debate. But they like to ask you these questions all the time anyway. And people are interested in your work, and you can get serious journalists to be seriously interested in what you're actually doing. And that's a plus, right? Because otherwise they wouldn't know who you were. And if you fill a niche in the kind of public narrative, you become the go-to person every time somebody needs to hear from that character in the narrative, right? So if you're the crotchety kids today, blah, 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 science used to be much better in my day, blah, 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 and you're willing to talk about it, you'll be called on all the time. And you'll pop up on Newsnight and on the radio, and let us go over to the same person over and over again. That happens. It happens on the positive side as well, right? So if you're somebody who's working on the attribution of extreme events to climate change, and you're moderately photogenic, and you can string two sentences together, you will be asked again and again and again and again, because they want somebody to play that role in the narrative that is being constructed independently of our science. Those can be good. Now, the bad consequences, of course, are that your papers are now continually quoted out of context, right? People quote an individual line, they distort what you say, the numbers get exaggerated, and then you find yourself being used to defend statements and positions that you would never have gone anywhere near had anybody actually asked you. It turns out that politics is not as nice as science. Now, science is not necessarily a nice place, but we have certain norms that we like to think of as being maintained. So you go to a conference, and I remember this happening to a graduate school colleague of mine, and somebody was sitting at the front of the when he was giving his talk. And the moment that he'd finished, this guy stands up and he says, "But you haven't cited blah 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 and blah 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 blah, 2012 and 2000." And they go, "But you must have cited, you must have read that, because those did that is the exact same problem, years ago. Why have you not cited them?" And this was a young graduate student, and they were somewhat intimidated by this rather aggressive, rather experienced person, and the whole Q&A was just like, everyone was like, "Oh my God, did you see what happened?" And it was a very tense time. It was not and somebody made him apologize afterwards, right? Because he was a bit of a dick. It's true. But that's in public, that's as bad as it gets, right? Nobody stands up and screams, "You lie," from the back of the hall. Nobody throws anything at you. Nobody puts a dead rat on your doorstep, right? Nobody puts a bag of poop through your letterbox, right? But when you get involved in the political discussion, or you get perceived as being involved in the political discussion, those things happen. The other bad effect is that you personally and your life and your opinions and your values get put much more under the microscope than would ever happen in a scientific environment, right? In a scientific environment, for the most part, people argue about the data, the evidence, the inference, the models. They don't argue about your background, where you came from, how you got there today, and whether you're a nice person or a mean person, or whether you said something in an email that could be misconstrued. Or you said something that was totally not misconstrued and you were just being really mean in an email, right? Those things don't come up very much in scientific conversations. They come up all the time in political conversations, right? This is a very different environment. And it's a shock if you find yourself thinking that I'm involved in a scientific discussion, and then suddenly you're actually involved in a political discussion. It can be a real shock to the system, the difference in how people react to you. And if you're not prepared, it can come as so much of a shock that people have wanted to leave the field, people have taken breaks, people have had really very serious impacts from these things. The other part of this, of course, is that the media reports, the discussion about whatever it is that you did, is generally wrong, right? It's conflated with a lot of other things. People try and string together some meta-narrative that you wouldn't ever have supported, but they use your study as some kind of key point in that. And you say, no, that's not what I meant. But nobody pays any attention to you because you are not the point, right? The narrative is the point. Okay, so the bigger consequence of that is that people see science being totally mangled. They see headlines not being supported by the underlying information. People lose trust in the media, rightly so. But then that kind of translates into losing trust in the science and the scientists themselves, because most people don't actually know a scientist who can tell them, no, that's all wrong. Don't pay any attention to the headlines. So current SciComm is not great, right? I don't know if that comes as a shock to you. There's a lot of people who are trying lots of different ways to be good and relevant and interesting. Twyla here and Paul, that I know, has done a lot. But in general, the stuff that gets consumed by the most amount of people is not very good, right? There's a lot of overgeneralization. They would say, oh, simplification. We don't want to dumb it down, but we just want the simple. But that leads to overgeneralization. Scientists say when it's just two blokes down the pub. Models prove. Well, let's not get into the philosophy of how models allow you to infer things about the real world. But okay. Deniers claim, I don't know, who are these people and what did they actually say? It's never really actually stated. And there's a huge naivety about what people want. What do policymakers want from our work? We have that naivety. Unless you've actually engaged with policymakers, you probably have no idea what the decisions are that actually get made and where the possibility for scientific input comes in, right? And if you're interested in that, really just sit down and listen to policymakers for a while outside of the media, outside of where the cameras are, and listen to how things actually work. It's very much more complicated than you might think. And so we come in with a certain naivete. this is true for all communications, right? Listen before you talk, which is hard, like, because I didn't listen to any of you before I came in. So, you know, and there's way too many words in my slides, and that's bad communication too. So I'm a bad practitioner of what I'm talking about. But please be nice. People need to listen, and a lot of times we're just talking at as opposed to talking with, and that's a real problem. We spend a lot of time complaining about the costs of doing business in a politicized environment. We should not complain, right? We are extremely privileged to be allowed to work on things that we just think of as interesting, and to explore things pretty much wherever they take us, whether it's to the ends of the world or to outer space or even further. We are very, very lucky. So when people complain about, oh, it's so mean that somebody wanted to see our data, or you know, they wanted me to explain this, or they wanted me to show that this was replicable, right? It just comes across as somebody whining when they're extremely privileged. And we should not do that. We should not be whining. We should not be complaining when people criticize us, right? I know it's hard not to complain when people they say things and they're wrong, and they're just, So yesterday I was reading something, and like somebody wrote in a blog post. I was going to bring it up, but I couldn't get the internet earlier on. But the thrust of it was NASA fraudster in chief. The litany of his many frauds over decades, and it was about me. I thought, oh, how sweet. Should I be angry? I'll explain a little bit why I'm not angry a bit later. Do you know what the deficit model is when people talk about SciComm? No. So the deficit model is the idea that demonstrably people know nothing, right? So you ask people, what is a greenhouse gas? You ask people, what's the difference between ozone and carbon dioxide? You ask people where emissions come from. You ask people, what's a cloud made of? And what you will find is that people know nothing on average, nothing. So there is very clearly an information deficit, right? We know things as a community that the wider public does not know. The deficit model is the idea that if we could only impart all of the relevant knowledge that we have to the general public, they would suddenly think like us, they would share our values, and we would all agree in some happy, non-political way to do things about carbon dioxide emissions, or air pollution, or water quality. Half of that is right, half of that is totally wrong. So, yes, there is a huge information deficit. One might think that we should fill it, because we know things and they don't. But the idea that just because people know the same things as us, that we would then share values and then all agree in some kumbaya moment about what to do about these things is a total fallacy, right? So when people complain about scientists talking in the public, and they often say, "Oh, you scientists, you're just following that totally debunked deficit model, you fool, because you're trying to impart information to people that do not have information, or have weird ideas about that information." You can just, people end up just like kind of going on rants about how stupid scientists are because they don't pay attention to the latest psychological literature. I get very tired of that because I know that, and I still think it's better to have an informed populace, even if they don't share my values, than having people just make decisions with total ignorance. But that's just my preference, my values. All right, never mind. Let's have something cool. All right, why do you want to communicate? Right? Do you want to change the world? That's the question. Why do you want to communicate? Why are you here? Right, I'm talking about communication. Why is anybody here? Right? Presumably, like, it's not because of my superstardom, right? Right. So it's because you're interested in communication. Why are you interested in communication? What do you want to communicate? Right? Do you want to communicate your thoughts on, I don't know, movies? Anyone see that movie? See, you guys are too young. It was a terrible movie. Terrible. There's a scene in there. They're all kind of a big room, like lots of computers, and somebody says, "Well, what about the models?" And somebody else says, "No, grid models can't save us now." Never a truer word. Literary criticism, also a noble profession, also a book that's total rubbish. Those are things that you could be doing, right? But if you think about why you're communicating, that often tells you what you should be saying and when you should be saying it and how you should do it, right? You have to be strategic in how you communicate, right? You can't just like, oh, well, I'm going to start a blog and then I'm going to communicate and everything's going to change. No, that's not how it happens, right? How do you connect to the audience that you want to talk to? Who is your audience? Think about these things before you start doing anything, and you might be a little bit better off. I'm just going to skip that. I'm bored with that already. Let's look at something cool. Okay, so what are the biggest things that are hard to explain? And I used to think it was the details of the chemistry of carbon dioxide, or the radiative transfer in the atmosphere, or what an aerosol is. But actually, those aren't the hardest things to explain. The hardest things to explain are not people. Well, obviously but it's really the nature of science, right? How does science work? People don't know scientists. They only know science mainly through movies, maybe through watching The Big Bang Theory, maybe from something dimly remembered from a horrible class that they took that they didn't do very well in because they were very bored and they didn't get the right answer, and nobody explained why that wasn't the right answer, and nobody explained why getting an interesting answer is worth getting. Anyway, people expect scientists to have all the answers, right? That's the image that is portrayed, right? Jeff Goldblum in the Jurassic Park, the first one. Oh yeah, he knew everything. Oh yes, well it's chaos. Ha 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 ha, boom. We're not like that though. People don't understand that. People are very uncomfortable with the provisional nature of science. The idea that, 2014 was the warmest year on record. No, 2015 is the warmest year on record. No, 2016 is the warmest year on record. Like, we keep changing our minds all the time as new data comes in. People have a very hard time with that. People also get very hung up on things that they perceive as important, but really are totally irrelevant. The difference between proof and inference, the difference between a theory and a hypothesis and a law, because they've gone through educational systems that have made these things into kind of reified concepts that don't actually kind of fit in with what we actually work out in the real world. So you can get into prove this to me. This isn't proof. And you're going, well, okay, what's your standard for proof? Well, I haven't really thought about that. This is a model, right? People don't know what models are. You show them this and you think, oh, that looks complicated. Of course, that is actually a model. It's a climate model, circa 1982, I think. One line of Fortran code. We no longer use punch cards. Most of you will be pleased to know that. But we still use Fortran, which some people, if I give this talk in a kind of more kind of computer savvy thing, and I tell them we still use Fortran, literally people are just like falling over in the aisles. It's quite amusing. What do models do? This is a much better view of what a model is, right? What you're seeing is atmospheric particles, so aerosols. Each of the different colors is a different kind of aerosol. The orange aerosols are dust, mainly coming from the Sahara, swimming across the Atlantic. The blue aerosols are sea salt particles being lifted from the sea surface by the force of the winds. White is sulfates coming from burning of high sulfur coal. You can see a lot of that in China. The green is organic carbon, black carbon aerosols, and you can see that coming from biomass burning in Indonesia and the like. And you can use stuff like this to really get people kind of into, how does it all fit together? Because you can see that the aerosols are being affected by the climate, by the weather systems. And because they're not transparent, they are affecting the temperatures and the weather patterns themselves. So you can talk about, the connectivity of all of these things. You can talk about the emergent properties of the climate system, both in the model and in the real world, that come about from the interaction of all the small-scale processes. You can see, the circulation around around Antarctica. You can see the storm systems. You can see everything kind of interacting. And you can see these big wave patterns that aren't inbuilt into the models, but emerge from the connection of all the different small-scale processes. And if you wait like 2 seconds, there should be a volcano that goes off just north of Madagascar. Oh, there it is. Okay, so that's producing sulfate aerosols into the system as well. So if you talk about models, if you show models as opposed to talking about models, you get a much better situation. So how do we, as individuals, go forward in this realm? First, do no harm. Okay. So the biggest mistake that people will ever make is letting the public relations officer write their press release for them. Never let this happen to you. Right? They have no idea what they're doing, and they will be terrible. I've been caught. Right. So we've had many public relations things, and I work for NASA. It's a federal agency. It has to go through multiple levels of approval before it ends up going out. And sometimes I haven't seen the last version. And the last version goes out, and it turns out that really important little phrase there about the uncertainties in blah, blah, blah disappeared. And then you end up with a situation where people say, NASA is ignoring the uncertainties. And I can't say it's that strange chap at headquarters, don't record this bit, who took it out. And it's just very, I'll give you an example a little bit later on, when we get to the fun part of this. People don't understand the context in which your statements and your research will be heard, right? There are a lot of, so the public relations people here, they're probably okay, because they do a lot, right? Columbia, they're pretty good. But, there's an example I'll use a little bit later. The group in Heidelberg, first time that they ever really had a big paper in a high-profile journal. The press release was a disaster, and this is one of the reasons why. One of the key things to do is to distinguish your personal opinion from what everybody else thinks. Because the fact of the matter is that you and I and all of us are totally interchangeable. We're not, if we're on TV or on the radio or we're in a headline or something, we are totally scientists from central casting, right? We are not individuals. It's got our name on it, and like the people that we know notice our names, but for most people, we are just J-blog scientists, right? We're not individuals. And so things that we say, whether it is really like just a very subtle point about, our group and that group over there, and we have a slight disagreement about some interpretation, we can say something, all the previous estimates were all wrong, when we're really referring to one paper that was cited, but then no. What comes across is that scientist says that all previous work is wrong. because we're not distinguishable, right? And so saying things that are our personal opinion, I think that group made a mistake, is very different to saying what everybody else thinks. So be very clear about what everybody thinks, right? When people say things like, oh, well, this is bigger, worse, smaller than expected, often nobody ever asks you, well, where did that expectation come from? What expectation are you even referring to? And very oddly, you think, oh, well, they mean the last IPCC report, right? That's the set of expectations. But no, it turns out they mean something else entirely. And in fact, this was already in the IPCC report. Yeah, boring. This is really key. And I've become much more evangelistic about this than I used to be. There's a huge gap between the paper that you wrote and the headline that might arise from it, right? People will read the headline, and most people will only read the headline, and that headline will be misleading. A lot of people will read the headline and say, oh, I don't think that can be right. And they will look further, they will actually read the article, but they will be unsatisfied because there is not enough information in the article to really demonstrate what it is that you're talking about or make the point that is being claimed. But then they go to the paper, if they can find the paper, because often you can't even find the paper from the article with the headline that's misleading because people don't know how to use DOIs yet, please. So if you find the paper, which takes effort, and you try and pick it up, and you can't read it at all because unless you're an expert and there's so much tacit information in those, it's almost impenetrable. And so people will scan it, they'll read the abstract maybe, they'll pull something out of that, but they're not really any wiser than when they just read the headline. So you need something to translate for people that want to know more, but who are not people in the field. And so providing accessible information in a kind of layered way that allows people to get closer and closer and closer to what you actually did is really important. Sometimes it's just enough for it to be there for people to feel more confident in the headline that they wrote, right? Because if people look and then they might not have time to read everything, but if it's there and they feel that people are talking to them, they often feel that there's more, they can have more trust in that result or in that conclusion than otherwise. If we don't do anything, that gap, that kind of hinterland between the paper and the headline is often filled by people who know nothing or who know a lot about how to fool people. All right, so so this is the important point. Scientists who communicate widely cannot avoid being advocates. Right? You cannot avoid it. If you think that you can communicate without advocating for something, I would like to see you try. Because anything that you're doing outside of your normal job, right, writing the paper and writing the grant and going to the conference, anything that you do outside of that, you're doing for a reason. Now, sometimes that reason is just pure ego. I want to be more important. That's an okay reason to be doing things. People don't generally admit it, but there's clearly people who are only advocating for themselves and for their greater intelligence compared to everybody else. Most people don't do that, though. Most people are advocating for a reason, right? They're advocating for you to think something different, to know something different, or to do something different, right? People need to be very clear about what they're advocating for. Because if you pretend that you don't have opinions, if you pretend that you're just doing these things out of the goodness of the heart, out of the goodness of your heart, and you don't even care if anybody's listening or not, okay? That's not credible, right? It's not credible, and it's not true. You do want to do something. So what is it that you want to do, right? So education is fine. Science literacy is fine. All of these things are fine reasons to advocate and things to advocate for, but you really need to be clear about what you're advocating for. So people that get a little bit hot under the collar and they say, oh, scientists shouldn't be advocates, it compromises their science, are basically saying that as long as I don't tell you what my opinions are or what I'm advocating for, you should trust me more. That seems backwards to me. Now, the real reason why you can't avoid this is because even if you pretend that you're not advocating, people will claim that you are. And then you will spend all of your time arguing, no, I'm not advocating, when clearly you are. And that's an untenable position to be in a debate, and it just undermines your credibility. So the key thing is, if people are going to tell you that you're advocating, you should own that. And you should tell people exactly what you're advocating for. Right? What are your values that coincide with your knowledge that make you want to communicate these things? People have to be much more explicit about that in order to get through this. So I'm experimenting with a graphical way of showing this. So tell me if this works for you. Okay, so you have different audiences. This is a professional audience. You are my colleagues. You might not appreciate that, but you are. You're not the general public. I have, when I say something along the lines of, I think there should be higher scientific literacy in the public, I imagine that most people here would agree with me. Anybody disagree with me? No. So because we share values. We share a value in an educated populace because we're academics, right? Now, in a group of fundamentalist theologians, that might not be the case. We would have disparate values, and therefore we wouldn't agree on that particular value system. So the risks, and there are risks, in me being a public communicator are actually pretty well tied to how much values I share with my audience. So the risks for me talking here are very small because we're all academics, we work in similar fields. I can pretty much say anything, and you might disagree with me, but I'm not really taking a risk in explaining my position to you. When I start to talk to groups that have very disparate values to me, that value things like tradition and family far more than education, right? Now I talk about something and I implicitly say that greater scientific literacy would be a good thing. They might hear, no, you're trying to undermine our tradition, which has a few kind of funny science things in it. Non-science things in it, and now you're a threat to me, and now I have a high risk that my communication is going to not just fall flat, but have a completely opposite effect. So risks and shared values kind of go together. So where we share values, there are low risks, but where we have disparate values, my position, my advocacy has a higher risk of kind of blowing back in my face. And it varies as a function of audience. Right, so for something like science literacy, actually that's a pretty well-shared value. I mean, pretty much any audience that I talk to thinks that people should be better educated, right? With a few exceptions. So the risks are low, and the share and the amount of values they're quite highly shared. If I advocate for a specific amount of research spending, now in public, people expect scientists to advocate for research spending on their own projects. Okay, we should spend $1 million on my research, and in public, there's no risk to that because that's what is expected. But in a professional environment, I think we should totally defund palaeoclimate and put it all into climate modeling, right? That would be a more contentious situation, right? Right. So the risks to my professional reputation would be higher in that case. If I want to advocate for a specific policy, like an increase in nuclear power to reduce emissions, now that's a pretty high risk thing, even in a professional environment, because we all have opinions about that. And it's also, there's a risk because it's a contentious thing in public as well. Right, so for some specific policies, if you advocate them, you are taking greater risks and people are going to argue with you more. Curiously enough, if I tell you who I'm going to vote for, because we're in an academic environment and that really doesn't make much difference to how we interact with each other, that's a pretty low risk statement in a room like this. But if I say it, you say, well, no, okay, it's slightly low risk. But if you do it in public, it's like it's tribal, right? And then, all bets are off. If you don't say a word and you don't advocate and you don't communicate, then there's no risk in the public because nobody's ever heard of you. But there is a risk to your professional reputation in the community because nobody's ever heard of you, right? And if you want your stuff to penetrate, you have to think about that. So communication and advocacy has risks, but then so does silence. And I add in one more. If you're going to make a career talking about scientific practice and improving the integrity of science, in the public, that just seems like a no-brainer. Of course, scientists should have integrity, and we should have no misconduct, and there should be no plagiarism, and we should give everybody that, of course. But if you spend all of your time implicitly saying that all of your colleagues are committing misconduct by talking about their science in public, then that isn't going to go down very well among your peers. And we can think of people who've gone down that road. Right. So, what works in science communication? Graphs, do they work? No, they're total rubbish. So a graph like this, you think, oh, this is very interesting. Look at the trend, and look at, you can see the standard deviation in the interannual temperatures there, but then, you've got the lowest bit. Oh, and look at what the prediction is for 2016. Okay, in a public audience, the amount of information in a graph like that is overwhelming. They have no idea what they're supposed to be looking at, right? They're supposed to be looking at the black dots, the red line, the blue line, the green dot. Like, what does it all mean? I'm looking. What does a degree temperature anomaly even mean? How do you measure that? I have no idea. What does it mean? I mean, this temperature. So I use this a lot. The temperature in this room, it was pretty cold when we came in, right? It's already gone up by about 2 or 3 degrees, right? But none of you are extinct, and the chairs haven't melted. And so how do you talk about these things in ways that connect to people and that demonstrate their relevance without getting caught up in technicalities and in graphs? This works much better. You go back in time. I don't actually have a time machine. You go back in time, 1894, Mendenhall Glacier in Alaska, and you go back to the same spot today, totally changed. Now, in a room full of the public, and you do a series of this, okay, you will hear audible gasps from the audience. You will hear people kind of take an intake of breath because you go before, after, before, after, before, after, before, after. And they get that things have changed. But they didn't get it because they saw a graph and processed it intellectually. They got it because they saw something change. It went straight through the visual cortex. It was processed instantaneously. Fast and slow thinking, if you want to read the Daniel Kahneman book about it. This works very well. And it's not wrong. Stories, people, putting people in the stories works really well, right? This is a much nicer photograph than the results that she's getting, right? This is a story. You're going there like it's painstaking work, and look, you've got all this. How much information is there that we're not getting? There's a great story just in one image, right? The process of science is fascinating to people. Why is she doing this? It seems pointless, but But then you can show people, no, scientists can have a lot of fun. Right? This is Kim Cobb, you might know her, drilling for fossil corals on Palmyra, which is about 5 days south of Hawaii. So some people have a great job, right? I feel a bit bad showing you this when the weather is so crappy here, but okay. One of the key things is the layering of information, right? You have to think about how much time people have, how much energy they want to put in, how smart they are, and like really, really smart people often have no time. So it doesn't matter how well targeted your communication is to those people. If they don't read it because they haven't got time, then there was no point. Right, so people have to be able to come into information as and when they need it, right? So if you think about ski runs, right, you know what? I mean, maybe some of you are total daredevils, but when you get to a mountain and you're going skiing, and the first day that you're there, you don't suddenly hit the double black diamond slopes. Well, not unless you're very brave or foolish. Like, you do a couple of the bunny runs just to kind of get your legs, right? Because you haven't really skied since last year, and, well, I've got to, okay, now I can do something. Now I've got a little more time. Okay, maybe I'll do some moguls, The point is not to go skiing, though fun as that is for the time being. But the point is, like, on a ski hill, you have different possibilities depending on how you're feeling at that moment and what your skill level is. Right? We should do the same thing for communications about science, right? What's your skill level? What are you feeling like doing right now? And sometimes even really, really skilled people still take the green runs. And sometimes really green people take the double black diamond runs. And having been there myself, that's not a good plan. But so if it was, you know what? It was better labeled, and I was just very foolish. I thought I could do it, and I couldn't, and I got stuck. So. But let that be a lesson. Okay, so this is more fun. So what happens when things go horribly, horribly wrong? Right. So this is an example, 2006. This is 3 examples, right? So there's this one from 2006 about methane emissions from plants. There was another one about that I was involved in, which was the 2014 warmest year, and there's another one about sea ice reductions. So, methane. Does everyone remember this one? 2000s, like some of the old folk will remember this one. So, the idea was that, and this is a high-profile paper in Nature, the idea was that leaves themselves were giving off methane. Right now, the fact that methane is it's not fully oxidized, and so you don't expect methane to be produced in oxidated environments, aerobic environments. So this is a real surprise, and so had it been true, it would have been a valid paper in Nature. Now, the previous week's news context had been about the reforestation credits, the RED process in Kyoto. So everybody's talking about reforestation and the role of planting forests to mitigate against climate change. Okay, so the press release was very clear. Plants. There was no caveating of anything. It was plants release methane. Right, that was the thing. And then the second part was methane is the second most important greenhouse gas after carbon dioxide in terms of anthropogenic forcing. Right, this discovery is important for understanding the connection between global warming and increased greenhouse gas production. You can see where this is going, right? Do trees share blame for global warming? Global warming, blame the forests. Go snub a tree, right? Ho 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 ho! Those scientists, they're so stupid. So the people that wrote the press release, they put out a second press release, like a few days later, after the press had been so terrible, saying, "No, that's not what we meant." And only the Guardian, to their credit, put in a correction, and you can't read it, but I'll read it for you. But it was very, very. The headline above overstated the more circumspect case outlined in the article below, which said plants emit up to 30% of methane entering the greenhouse gas. Scientists have just discovered this, but to conclude it is a new cause of rising temperatures is mistaken. So that's like kind of, okay, well, we were kind of wrong, but it's not our fault, really. Like, But of course, nobody read the correction or the second press release, right? And, and then 2 years later, 3 years later, 4 years later, when people try and replicate this, nothing, right? So, score 1 for more confusion in the public. This is another one. So NASA did a study on why 2007 particularly was such a bad year for Arctic sea ice, right? So if you think about the graph, right? So sea ice has been going down, 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 down. 2007 it went whoa, and it kind of popped back up again. And then 2012 it went down again, and then this year was the second lowest sea ice. Anyway, 2007, big deal, very very rapid drop. The press release said the rapid decline in winter perennial ice was caused by unusual winds. Unusual atmospheric conditions compressed the sea ice, loaded it onto the transpolar drift stream, and then sped its flow out of the Arctic. Okay, and then it rapidly melted in things. And you say, okay, well that's good, but there's no context. So it was caused by unusual winds, right? So no talk of the trend, no warming, no nothing. It's the wind. Antarctic, it's just the wind. It's not us. It's not climate change, it's the wind. I realize that's not a very credible website, but still. Unusual winds caused Arctic melts, not global warming. Didn't say that, right? It wasn't explicit in saying that, but that's the narrative that people want to buy into. So if you say that something was caused by something else, and you don't mention the other things that are changing the background state, then people think that you're contradicting that previous expectation. They want to think that. So this one was my fault. In 2014, it's odd. I inherited this from the previous boss. And so there's a group of people at GISS who put together these temperature data sets, and they update it every month, and then at the end of the year they come up with an assessment of where we are, what the trends are and things. Okay, 2014, in our record, 2014 was the record warmest year. It was also the record warmest year in most of the other records, but not all of the other data sets. Now, of course, these are estimates, right? And so there's an uncertainty associated with each of these estimates that depends on the interpolation scheme that you use, how you've corrected for the urban heat island effect, how you've melded the ocean temperatures with the land temperatures, et cetera, et cetera, et cetera. So because the gap is so small, right, and because there's uncertainty, if you do a kind of like, what is the probability that either of these could have moved up or down to change the ordering, right? You can do that calculation. It's pretty straightforward. And what we put in our in our press conference was we said, okay, no, this has a 38% chance of being the warmest year, right? So it's more than any other year, but it's not like definitively the warmest year in the real world, right? Because we have uncertainties in how this works. And these, and we do a big deal about how these rankings are a little bit fragile. Sometimes, you get more data in, things move around a little bit as they go. So that was the press release, which was a line that had been in the last version that I saw that said this, but it disappeared in the final version. And then the Daily Mail gets hold of this. We said 2014 was the warmest year on record, but we're only 38% sure we're right. And you're going, oh well, okay, that's not terrible. But this is the funniest bit. GISS claimed its analysis showed that 2014 was the warmest year on record, but it emerged because I put it in the press conference in front of everybody and told everybody what the answer was, that the GISS analysis is subject to a margin of error. Oh my gosh. Me. Gavin Schmidt admits there's a margin of error. Stop the presses. So I don't talk to David Rose anymore, as you might imagine. Yeah. So, anybody Buffy fans? Oh, wow. You guys, you're missing out. Season 6, particularly. Anyway, Buffy the Vampire Slayer, right? She had this cute witch friend. You know, they went through high school together. They battled demons. They got rid of vampires. And there's one episode, I think it's in season 6, where Willow, this is Willow, right? They open a portal into another dimension where Willow was evil Willow, right? Where she was an evil vampire Willow. And everyone's going, no, not Willow, she's so cute. But like the vampire Willow was pretty cute too, but anyway. Sorry, bad. So they have all these scenes where you've got evil Willow and good Willow, right? You end up, if you're a public person, you end up with your own doppelganger, right? You end up with somebody that if you Google their name, you'll find they work at the same place of work as you. They've published the same papers as you. But they're the worst. Like, terrible, terrible people. People that don't care about scientific integrity. People that make up numbers left, right, and center. People that lie, cheat, steal, everything. And it's you. It's your picture. And you're going, wow, who knew? I thought I was a nice person. I still think I'm a nice person. But the key is that you have become something else. You have become symbolic, right? And when people are using you in a symbolic way, they import all sorts of things onto you that your symbol stands for. There's nothing to do with you. You know, somebody I mentioned this article earlier. Somebody, you know, accused me of being the fraudster in chief at NASA, and you actually look at what they're claiming. They're blaming me for something that Tom Weagley said in an email to Phil Jones. Sorry, how does that work? They're blaming me for something that happened to the NASA data set when they started to incorporate better adjustments for time of observation biases in the US historical climate network in 1999, 5 years before I even started to work for NASA. They're blaming me for something changing a decade before I started being responsible for it. I'm going, that's interesting. Like, how does that work? How does anybody actually think that that's a credible argument? The answer is they don't. Right? The issue is not to make a credible case that, you know, what we do is wrong or there are problems or that there is a margin of error. But the idea is you throw up symbols, you create icons, and these people are iconoclasts, and that's what they take down. So you end up with this internet doppelganger who looks like you and sounds like you and, you know, lives at your place of work, but it's not you, right? They're the worst people in the world because you're just being used as a symbol. And when you get to that elevated status, you can go, oh, okay, I am now a symbol. I have transcended my physical form. Ha ha ha, no. I have no idea how to deal with that. I mean, it's like, but it will happen, right? You know, like, you know, if you become big names in a public communication sphere, you will be the butt of this kind of nonsense. And you have to be okay with that. You have to be able to distinguish between things that are actually about you and things that are about your internet doppelganger. And you have to be very clear that those are two different things. Because if you take all of the things that they say about that person, personally, you would never get out of bed again. So don't do that. All right. But this is the issue, right? If you don't want to be criticized, and if you don't want people to argue with you, if you don't want people to call you names, if you don't want people to disagree or misrepresent you or anything, don't do anything, right? As I said before, you risk minimizing your role even in the professional circumstances. You risk the influence that you might have had to put the general public either in a higher level of science literacy or a better policy, whatever. But there are risks. But if you don't want people to attack you, if you don't want people to argue with you, do nothing. Because it can be lonely, just sticking your head above the parapet and waiting for people to take pot shots at you. But it becomes much harder if there's more than one of you. And it becomes almost impossible if everybody is doing it. Now, it isn't to say that everybody should be doing it, but we rely on individuals and high-profile individuals far more than we should. One of the worst things that people say to me is I go to a conference and they say, oh, I saw you on TV and I saw that blog post that you wrote, or I saw that you were tweeting about this. And then they say, I'm so glad that you're doing it because it means I don't have to. And that just kills me. I understand why they're saying that. I understand that we expect people like me and Twyla and Paul to be champions, to take what we do and express it to the real world in ways that other people can understand, and you don't need to be involved. But that's not a sustainable position in this particular world. It's not sustainable for like 5 people to carry the weight of all of the science and all of the understanding that our community has built. It's not a sustainable project. People have to stand up. And if we stand up more, then the things that I was talking about, the risks, the problems, they get diluted and they become much more manageable. Because let's face it, we have a lot of work to do. All right, thanks.